Hello everyone, and welcome to the titration of acetic acid lab video. This is a relatively straightforward experiment that's designed to give you practice titrating. And so this week I want you to work slowly and carefully. Usually the quickest way to finish an experiment like this is actually to work slowly and carefully, because if you rush, you make mistakes, then you have to repeat over and over. So usually the careful folks are actually the first to finish. So be mindful of that this week. Work carefully, think about what you're doing, try to avoid mistakes, and don't be shy about asking your instructor questions. So our other goals this week, in addition to practicing titration, is going to be to practice titration calculations, learn to identify outliers, and also learning how to generate quality data tables. So what are outliers? Outliers are bad pieces of data, essentially. When you do an experiment, you run multiple trials, you may find that you have some data points which don't agree, some bad data points. We call those outliers. And we're going to want to throw those out so they don't sort of corrupt the rest of our data, so they don't damage our accuracy and whatnot. So in this experiment, we're going to be looking at them more qualitatively and sort of just talking about them conceptually. So I want you guys to think about this concept. Is this a good data point? Should I keep this data point? And later down the road, we'll have space to get into some more quantitative sort of analysis of what's a good data point versus a bad data point. There's a link right here listed about how to find outliers. And if we actually bump out of PowerPoint here, if we just Google search calculating outliers, the first one that comes up is actually a resource that I like quite a bit. It's this WikiHow one here, and so it talks about how to quantitatively assess if something's an outlier, so how to do the math. And so it's fairly lengthy. There's a lot of steps to it. None of the steps are actually hard. There's just a lot of steps to identifying if something conclusively is an outlier and should be tossed out. So this WikiHow resource about calculating outliers is great, and you're welcome to explore it. But for now in this lab, we're going to just be looking at outliers in a more qualitative fashion. And so another important piece of another important skill I want you to gain from this lab is to learn to generate quality data tables. So making data tables is one of the most important skills you can pick up from a science class, and so we're going to be practicing that here. All right, so let's talk about preparing your lab notebook. So before you come to lab, you want to make sure you have your purpose recorded in your lab notebook. So the purpose is going to be a paragraph that describes not only what the goal of the experiment is, what problem we're trying to solve, but also what are the learning goals here. So like those objectives we listed on the previous page. What does the instructor want you to hopefully learn from this experience? In addition to the purpose, you're going to need a procedure. And so you want to make sure the procedure is clear and relatively detailed, because again, you may need it down the road for that lab exam. And also, this is practice for when you guys might be writing scientific papers or such. And you want to make sure it's sufficient detail for an experienced chemistry student, so someone who knows at least as much as you, to duplicate exactly what you did in the experiment. And so it's important that you include specific names for pieces of equipment. So like the thingy, obviously the thingy is not going to be detailed enough, but you can't just say like flask, for example, because we have lots of different types of flasks. There's round bottom flasks, there's Erlenmeyer flasks, there's volumetric flasks, and the list goes on and on and on. So make sure you specify which type of flask you're talking about. So be specific about your names of items. And also, be specific about what volumes of glassware you use. So don't just say that you used a beaker, specify what size beaker you used. Because again, we want other people to be able to copy the experiment we did. And the final thing you want to have prepared in your lab notebook is an area for your data. So you want to include here a location to record the concentration of sodium hydroxide. You're going to get this from the side of the bottle in the lab. If you don't record this value off the side of the bottle, then you are going to be in a lot of trouble when it comes to calculating your answers later. You really need this value. Make sure that you record it. In addition, you're also going to need the volume of acetic acid that you pipetted. And so you'll be using volumetric pipettes here, so make sure that you pick that you record what volume of volumetric pipette you used. That's going to be important for your calculations down the road. So in addition to the to the location for those, you're also going to need to create a data table. It's going to be a pretty big data table. You're going to want 4 columns and 11 rows on this data table. And on the next slide, we'll actually spell out what should be in each of these rows and columns. And that'll hopefully make sense shortly here. And then finally, what you're going to need is going to be, you're going to want to leave a pretty significant amount of empty space following that data table so that you can record any observations that might come up during the experiment, as well as have plenty of empty space for recording the class data. So after the 2 hours are up, the 2 hours of titrations are up, you're going to want to record on the whiteboard your data. And so we'll essentially have a big pool of class data on the whiteboard. And we'll be talking about which pieces of data might be outliers, which ones we want to keep, which ones we might want to toss out, what were some possible sources of error, and just trying to understand all that data that we have in front of us. So here we have an example of what the data table in your lab notebook should look like. And so notice that above the data table here we have a descriptive title. So it says individual acetic acid titration data. So you want to specify which data this is, because you're going to have individual data as well as class data. And you also want the reader to know what experiment that they're looking at here. So it doesn't have to be creative, but make sure that the title of your table makes it obvious to the reader what they're looking at. And so in the left column, you want to put all your trial numbers. So I've put trials 1 through 10. So your goal here is going to be to obtain 5 titration trials that agree with each other to within 0.05 milliliters. And you're hoping to do that within 2 hours. And so that may not happen, but do your best to try and get those 5 titration trials that agree with each other very, very well. And what that means is you're probably going to be running more than 5 trials. You'll probably have to do significantly more than 5 trials to actually get those 5 really good ones. You might have some bad data points you'll be tossing out. So anyhow, leave lots of extra space here. Although we're only keeping 5 trials, leave yourself space to record 10. And you might even need to record more than that, but I doubt you'll get through much more than that in the 2 hours. So that's how to prepare your lab notebook. Let's talk about in the next video what the reporting is going to look like for this lab. Thank you. Bye.